Hello there, my name is Brian, and I'm going to be your instructor for the Spring 2021 quarter of CSC 143, Object-Oriented Programming and Data Structures at North Seattle College. Before we dive into today's material, I want to talk a little bit about the meta aspect of how this course is going to be run. On the class schedule, you've seen how this course has a time listing of Tuesdays from 6:30 to 7:30 p.m. virtually online. We're going to reserve this 1 hour time slot for office hours. And perhaps to your delight, these office hours are going to be entirely optional. You can take this class, this entire quarter, without ever seeing me once live. So you don't have to attend these. These are totally optional, but I do recommend you attend them if you have questions about the course material or the projects or the exams or anything else you'd like to talk about. The actual lecture content is going to be posted on Mondays and Wednesdays as pre-recorded video lectures for you to watch on your own time. These videos are going to be about 1 hour each, and I'm going to post them all to YouTube. So like and subscribe, am I right? The reason I like YouTube is because it's a widely available platform that's got a lot of great accessibility features. If you check out the timeline below, you'll see how there are different checkpoints available for different timestamps in the video that divide the video up into different chapters, so you can quickly navigate back and forth between specific topics within a given lecture. There's also a subtitles button, which is either on this side or this side of the video, depending on how this gets flipped, which shows the YouTube's automatically generated subtitles below, so you can watch along without actually having audio enabled. Now, these aren't perfect, but they are quite good. I'm actually really impressed by how that came out last quarter. So I do recommend you use the subtitles if you're listening to these videos in a quiet space. And the third thing I want to point out is that you can speed me up and slow me down. If you click on the gear icon, you can select a playback speed for these videos up to 2x, I believe, or down to 0.5x. And that means depending on how quickly you're absorbing the content, you can always play back the video at a speed that you prefer, rather than having to sit down through the normal default length of about 1 hour per video. Okay, I think that's enough to get us started with the actual content, so let's go ahead and dive in. Enjoy the show. Hello again, this is Brian, recording the very first video lecture for CSC 143 for the Spring 2021 quarter. In today's lecture, we're going to go over some details of the class and what you can expect and how the class is going to be run, and then we'll talk about some more technical topics, including a quick review of Java and a tour of the Git version control system. Let's begin. And before we actually get into any of that, I want to talk about Fibonacci numbers and why we might care about them. In mathematics, the classic Fibonacci sequence is formed by a series of numbers f sub n, where each number is the sum of its two predecessors. So formally, for any f sub n, it's going to be equal to the sum of f sub n minus 1, the number that comes immediately before it, and f sub n minus 2, the number that comes 2 steps before it. And we're going to start out the sequence with f sub 0, the very first number, as 0, and f sub 1 as 1. So if we write this out, we're going to see this number pattern 0, 1, 1, 2, 3, 5, 8, 13, 21, and so forth, up to infinity, forming this actually pretty interesting shell-like shape, sometimes known as the golden ratio. And the question I want to ask you is, how would we actually write this Fibonacci sequence out in a computer program? Here is a recursive Python function. We define a function called fib. It takes a single parameter I. For our base cases, we have I equaling 0. If that's the case, return 0. I equals 1, return 1. I is the index, by the way, into the sequence that we're trying to retrieve from the function. And otherwise, if the index is greater than one of our base cases of 0 or 1, we're going to return the recursive call of Fibonacci I minus 1, that is one step behind, and Fibonacci I minus 2, that's 2 steps behind. So when those eventually reach the base case of I equaling 0 or I equaling 1, it's going to produce the summation up to the index that we're currently asking about, and give us the final sum for that Fibonacci number at that index. This, by the way, is an old drawing of Leonardo Fibonacci, who is credited with coming up with this sequence. But I believe there's actually some people before his time who came up with something similar as well. So in Python, if we want to call this function in a loop, we can use this for each syntax for I in range of 10, where range is going to produce an iterator from 0 to 9 inclusive, and inside the body of the loop, we'll just call Fibonacci and print it out. This man here on the right is named Guido von Rossum, and Guido is the creator of Python. So we're going to ask him what he thinks this sequence will produce. And if we would ask him, he would give us 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. Sounds right. Let's keep going. Now let's say Fibonacci asked Guido the 5,000th Fibonacci number. The question I have for you now is, how long will it take for Mr. Guido von Rossum to respond to Mr. Fibonacci here's inquiry? I'll give you 5 choices. Instantly, 5 seconds, 50 seconds, 5 hours, or 5 billion years plus. Let's assume this is running on a fairly modern computer with a decent amount of processing power with it. I'll give you a second to think about it, and then we'll talk about the answer. Okay, hopefully you've taken a second to think about it and picked one. Please do pick one, just for entertainment. And you might be surprised to hear that the actual answer here is 5 billion years plus, which is really, really surprising, right? This seems like a pretty simple and trivial mathematical computation that we can do by hand without too much effort. It would just take a while, but why would it take a computer so long just to compute the 5,000th element of the sequence? It would probably be faster for you to do it by hand than for a computer to finish, even a modern desktop computer. Well, what really happens here in this recursive Python function? We have this entry point Fibonacci of I, and we've got these simple base cases. Those return extremely quickly. That should take no time at all. But when we hit these recursive calls, what we end up doing is producing 2 recursive calls for every single function call to fib. This is going to actually result in exponential expansion of the number of function calls that we need to do. If I call fib of 5,000, that's going to produce 2 function calls, fib of 4,999 and fib of 4,998. Then each of those calls is going to produce 2 more calls of its own. And each of those is going to produce 2 more calls, and all the way down, by the time we hit fib of 0, there's going to be an exponential amount of calls to fib. And these will take a tremendous amount of time to compute. 2 to the 5,000, by the way, is about 1.41 times 10 to the 1,505. That is a gargantuan number. Even if we had an extremely fast computer, even if we had the fastest computer on Earth today, we would not be alive by the time it finished computing the result of fib of 5,000 using this function, because we are effectively making something like infinite number of function calls by the time we get to fib of 0. So here is a old-ish sketch of Hercules slaying the Hydra, where this Hydra is this mythical creature that when you chop off one head, 2 more heads spawn. And in this class, I want to refer back to this metaphor of Hercules slaying the Hydra, because we want to be like Hercules in that we kill the Hydra at the very end, we solve our problem, but we don't want to get stuck in this loop of cutting off one head only for 2 to spawn more, and us never actually reaching termination for our functions. We want to talk about the way we design our programs such that they don't face this issue of 2 more Hydra heads spawning every time we cut off a Hydra head. Instead, we want to talk about programs in a way that we want to design programs in a way that shape their behavior such that we try to avoid this problem as much as possible. Okay, now let's talk about me. Hello, my name is Brian. I am your instructor for CSC 143. You've already met me. I come from Texas. I was born and raised there. I lived there for 20 years while I got my master and bachelor's degrees at the University of Texas at Austin, so hook 'em horns. That was where I also did a couple of my first internships as a software developer. My first company was with Spiceworks. My next company was with Retail Me Not Inc. They're both based in Austin. And now I am a full-time engineer at Microsoft, working on the Microsoft Edge browser. I also teach on the side here at North Seattle College. When you saw the class schedule, you might be wondering how the heck you pronounce my last name. It's spelled C-U-I, the English way. That's the Chinese character you see on the screen. How do you pronounce that? Kui? Is it Kui? And I want to say that you can pretty much call me anything. I'm not going to be too worried about this. People ask me all the time how you pronounce your last name, how I pronounce my last name. The Chinese pronunciation is Cui. The Americanized pronunciation is Kui. You can also just call me Brian. That's perfectly fine. So you can call me whatever you're familiar with and what you're comfortable with. I do want to also, though, point out that I still am your instructor. I'm sadly not your friend. I am your mentor. I'm your coach, but I'm not your friend. So, that's kind of like a mean thing to say. I know, but I want to be your friend, but understand that we still have a teacher and student relationship. So while I want us to be casual, I don't want us to be too casual. So keep that in mind when we ever have a discussion about the course. All right, let's talk about class objectives. The four main objectives for this class are understanding and applying object-oriented design principles in programming. That's the OOP part. Writing code that's efficient, extendable, and maintainable. Learning how to think critically about program implementation decisions. And finally, gaining exposure to industry standard tools and techniques. So with this first one, understanding and applying object-oriented design principles in programming, this is very much the object-oriented programming part of this class. We're going to learn about classes. We're going to learn about how inheritance works between classes. We'll talk about encapsulation and how we want to hide data so that we can abstract away the functionality of a class to any clients of that class. And we'll talk about polymorphism, how certain classes can substitute other classes without external clients knowing. This next bullet point, writing code that's efficient, extendable, and maintainable, that is the data structures section of this course. We're going to learn about lots of ways we can organize, store, and retrieve data. There are different ways there's different trade-offs to each of these data structures that enable them to be more performant in some cases and less performant in others. Some of the readings that I have you assigned throughout the quarter are called the solid principles, where each letter in solid, S-O-L-I-D, refers to one principle that we'd like to adhere to when we're designing classes and when we're designing data structures. I'd like you to read these week over week so that you can have a general sense of what makes good class design versus what might be bad class design, so that we can better isolate ourselves from issues that we might run into when scaling up or providing our programs to external clients. This third bullet point here, learning how to think critically about program implementation decisions, this is going to be covered a lot in the exams and in the projects. And when I talk about think critically, I want you to have an appreciation for the things that we learn in this class, the different kind of data structures, the different kinds of object-oriented programming principles, but I also want you to consider the differences between them and think really hard about why certain structures are designed this way they are, or why certain structures would be better suited for certain applications and not others. In the projects, I'm going to have you not only write out and develop some structures or classes, but at the very bottom of the project descriptions, I'll be asking you some thought-provoking questions about why things are the way they are, and maybe can we come up with ways to do them better. In the exams, we'll see kind of the same thing. There's going to be some open-ended questions about what limitations and benefits there are to a given structure or a class design, and how we can improve them or how they compare to other designs that we've seen so far. Finally, this fourth bullet point, gaining exposure to industry standard tools and techniques. I want you to come away from this course with practical skills that you can take elsewhere, whether that means a future class at a different university or a professional gig that you do to make money. And in order to present these technical skills to you, these practical skills, I want us to spend some time with the very practical tools that I use day to day, and I think would be valuable to you in your future endeavors. These include things like command line Java. We'll explore a little bit how we can run and compile Java from the command line without the help of an IDE, the Git version control system that I think will benefit you from the time you learn it to the end of your lifespan, so that you can manage the versions of your projects over time without ever having to worry about losing progress. And we'll be using the IntelliJ IDE in this class. We'll talk more about IntelliJ pretty soon, but I really like IntelliJ. It's a modern IDE. It's got plenty of great features, including a really robust debugger that we'll be exploring pretty soon. Now let's ask a big question. Is this class for you? And what you're going to need coming in is a strong understanding of programming constructs. These are the basics and fundamentals of programming: variables, conditionals, loops, functions. Having Java knowledge is preferred, but it's not entirely necessary. Having Java knowledge coming in is going to help you a lot with the syntax, but I wouldn't consider it a requirement for the course. A lot of these fundamental principles that you'll learn in other languages are going to translate pretty well over into Java. This class does have a decent amount of time commitment. You can expect something to like 6 to 10 hours a week on projects and studying. The 6 to 10 hour range seems kind of wide. It's because some people can do the projects much faster than others. I don't want to have specifically a time bound that I want to recommend here because I want you to take your time on these projects. But I do want to set expectations straight that these projects will take some of your time. And I do recommend that you start early so that I can give you help along the way. There's going to be a lot of problem solving in this class. I expect you to be comfortable with independent research and experimentation. If you see a bug in your program or a crash in your Java IDE that you've never seen before, I want you to be comfortable and go out of your way to try and figure out on your own before you try to ask for help. That doesn't mean I'm not going to be here for you. It just means that I really recommend you have this sense of independence and self-capability that is going to enable you in the future to work on your own projects without fear of running into things that you don't quite understand. This class is not going to feature what I like to call cookie cutter solutions. In some more basic programming classes, you can probably get away with just doing the same thing that you had done a bunch of times before, like writing a for loop or writing 2 nested for loops or writing just a bunch of if statements. I don't want you to get into that mindset of thinking that you can just copy and paste what you did in the past and just adapt to a new problem in the future. That is not what this class is about. This class is going to require you to come up with new code that maybe you're not comfortable with, or maybe you haven't seen before, but it's going to be something that is going to introduce to you a brand new concept or data structure or idea. Perhaps the most important question to ask, though, is do you enjoy programming? There's going to be a lot of programming in this class. I don't want programming for you to be a means to an end, maybe a means to an end of making money, because programmers get paid a lot, which is true. But if you don't enjoy it, I don't know if it's worth it for you. That's a real question that you're going to have to ask yourself is if you struggle with programming, if it's not something that's an enjoyable experience, and from time to time it really isn't, I want you to seriously consider whether or not you would want to consider down this route of studying computer science and picking up programming as perhaps something you do professionally. So the official textbook for this course is called Building Java Programs, a Back to Basics Approach. And what I want to point out here is that this textbook is actually quite expensive. If you were to buy this used on Amazon, it would still cost you $165 to get it used, which I think is absolute insanity. And so this is the official textbook for this course because it was kind of not really imposed upon me, but it was given to me as the book we're going to use when I first started designing this class. But I think it's absolutely ridiculous that anyone would have to pay this sum of money for information that's totally and publicly freely available online if you look in the right places. Yeah, if I were to buy this, I would be poor. So this textbook is completely optional. In fact, I really recommend you don't buy it. I would much rather have you ask me where to find the right resources for this class so you can do research on your own rather than having to buy this book and depend on it. If you do end up buying this book, I can probably give you chapter recommendations for what to read, but then I have to go pull out my book and figure out what things correlate from the book into this class. So again, don't buy the book, save yourself some money, and instead try and find the resources that you need online. Get a job. So as part of the fourth bullet point for the objectives for the class, that is having that hands-on practical knowledge that you can take elsewhere, I do want to spend some time in this class to talk about how we can take our knowledge that we learned from this course and translate it into a professional career and what it takes for you to land a software engineering role at a tech company like Microsoft or Google or Facebook or whatever is super exciting to you these days. We're going to spend some time talking about how the things we learn in this course are going to relate to the kinds of questions you'll get during a technical interview. This book on the left here, Cracking the Coding Interview, is the go-to book that a lot of people recommend, and I recommend that you pick up if you want to get started on this kind of career path. We will talk a little bit about resumes and how you can shape your resume to be a great representation of yourself and your skill set and something that will look good to potential employers. We'll talk a little bit about, I guess, business strategy and what your potential career path could be from this course onwards when you get your degree in computer science when you get your first set of internships and beyond. This material is going to be optional. You don't really have to pay that much attention to it if you don't care. If you're not interested in computer science as a profession or programming as a profession, then you can safely ignore most of these concepts. I'm not going to ever quiz you about what things belong in a resume. But I still might ask you some interesting questions that would be questions asked on a technical interview that also relate to the things that we've learned in this class, because I think they would be a great application for the content. Okay, this is the last slide. Here's a link to the class website and syllabus. It's pretty simple to remember. It's my name, briancui.com/CSC-143. And here's where I want you to find all the information relating to how this class is going to be run, the expectations, what assignments there would be, all the project content, the grading, details on the exams, etc. Let's go ahead and open this up and dive in. All right, I've pulled up the class website at briancui.com/CSC-143. At the very top, we have the most important links and information. We are going to be having Monday, Wednesday recorded lectures that I'll be posting on YouTube and sending out to you on email. And Tuesdays, 6:30 to 7:30 p.m., Zoom office hours, where you can hop in, say hello, and ask me questions. You can email me at brian.kui@seattlecolleges.edu. Canvas is where all the assignments, all the quizzes, all the projects will be posted, including the grades. But otherwise, we won't really use Canvas all that much. Piazza is going to be our course discussion forum, and it's going to be a place where you can ask questions and get answers from me and other students. We're going to put most of the content in the class on Piazza. And finally, this third link here is a link to the notes on GitHub, which we'll be posting every single week. When you open this link, you'll get to see a folder of every week's lectures, and inside those folders, you'll find the relevant presentations and code projects that you can open up on your own computer and try out for yourself. Typically, I'll release the pre-recorded lectures probably a day or two before actual Mondays and Wednesdays. But I think it's important that you make a schedule for yourself as far as watching them goes. They'll be about 45 minutes to an hour each. The earlier ones in the quarter tend to be a little bit longer because we have to review more content. But I really recommend that you just allocate some time on your calendar to watch these at any given time during your week. I don't expect you to necessarily watch them on Monday or on Wednesday. I do recommend you do that so that we can maybe talk about it on Tuesdays at office hours if you do show up. But I would like you to have it done by the end of the week. That way you can stay up to date with the class material, because the project deadlines, the quizzes, and the exams, those deadlines are not going to shift around based on your lecture watching schedule. So do watch them week by week. I really don't want you to watch them all at once right before the exam. Make a schedule for yourself and try to be disciplined in that aspect. Again, office hours are also completely optional. You should find an invitation to each week's office hours in your email inbox, so watch out for that. You don't have to attend any of them if you don't want to. You can attend every single one of them if you want. I'm not going to judge you either way. So if you do have questions for me, it's a great chance to get one-on-one or live interaction from me and all of the rest of you. Depending on how busy office hours are, I may or may not try to balance out the amount of time I'm allocating to every question. So if there's a whole bunch of you that show up and have different kinds of questions, I may not be able to fully answer your question by the time I need to move on to somebody else. And that's just a matter of fairness. I don't want to get too caught up on one person and not have a chance to address other people's problems. So I do actually recommend that you ask on Piazza whenever possible, and then fall back to email when you need something specifically from me. That way we can have a broader discussion that the rest of the class can see, regardless of whether or not they attend office hours. And that discussion can happen offline and asynchronously rather than whatever limited time we have available during this 1 hour section each week. Scroll down a little bit and you'll find our weekly schedule. This is broken down week by week, lecture by lecture, and we'll see what content we should expect, the readings I'd like you to do by the end of that week, and the to-dos I'd like you to get started on for that week. When it comes to the readings, please have them done before the start of the next week. These readings will typically relate to the content that we learned this week. I'll talk about the readings in a little bit more detail later, but I intend for them to be short and pretty interesting. I don't want you to get bored reading these readings. I want to only post things that are relevant. I don't want to waste your time. As far as the to-dos go, please get started on these as early as possible. This week's are going to be install Java, get started at Project Zero, join Piazza. As far as projects go, the first project is going to be due in a week. That is on the 14th. And then every other project after that is going to be due at least 2 weeks from the day that they're posted. And they'll be posted, they'll be announced on Piazza. You can submit them via Canvas, but you can actually find all the projects available right now if you scroll down at the bottom of the website. Let's talk about how we're going to communicate in this course. We're going to be using Piazza as our online course discussion forum. You may or may not have used Piazza before. I think it's a pretty effective platform at creating this in-class community where we can have this, we can have discussions without necessarily being together in a lecture hall or in the same set of office hours. The format of Piazza is it's question and answer. You post a question on Piazza, and every other student in the class can see that question and answer that question for you. I can also see your question and answer your question for you, but I recommend that you try to formulate your question in a way that will allow other students to help you, and I also really want you to try and help out other students who are having problems. I'll of course step in whenever there's something administrative or specific for me, but typically I want to be kind of hands-off here so you can discuss among yourselves how to solve certain problems. Granted, Piazza being a public platform means that I don't want you to post any information that you would consider secretive. That includes significant parts of your own code in your projects. Your projects are going to be your own work, and I wouldn't want you to share out your entire project zip file on Piazza. That would be no good, and I'll take that down. But again, I do want you to use Piazza as our course discussion forum. And once you sign up, you'll also start getting email notifications from me whenever I make an important post. That's enough for an overview. Let's actually go into Piazza and see what's going on. You should have gotten an invitation from me to join Piazza for CSC 143. And when you open it up, you're going to see a 2-column layout where the left column is questions that people have asked or announcements that I have posted, and the question on the right side when you open a question. So there's a note here. A note is like an in-between. A note is a non-question, but it's a post anyway. Just welcome to Piazza. You can read a little bit more about that. And if you hit the blue new post button, you can ask a question to your other classmates or myself. Select a folder for where that question belongs. Let's pick other, and we'll have a question like, how do you eat a banana? I like to eat bananas from the stubby side. Some people like to eat bananas from the stem side. So here is my collective question to you all, which is, what side do you start with when you eat a banana? Let's go ahead and post this question to CSC 143. And what'll happen is it'll show up here on your left side feed as unread. And then the student view is going to have a box that says the student's answer, where you can collectively construct a single answer. So in this box, it's like a wiki style answer that you can provide for this question. So one way of you all collectively answering this question is maybe you all concatenating your answers together in a single box. The other way to go about it is actually through this follow-up discussion section here. So let's say for a moment that I answer this with, I like to eat it from the stubby side because you can get rid of the nip. When I submit my answer, this question will go as answered. It will no longer show up as highlighted red here. And you can still provide a student answer here. The reason it doesn't show me that box is because I'm not a student in this class, I'm an instructor. But you can also post these follow-up discussions, which are questions on top of questions, or just a space for further discussion. For example, I might follow up with, this is how monkeys do it, apparently. Once I post this, it'll start out in this unresolved state. And what that means is this is a question that hasn't been answered, as a follow-up that's not been resolved. Anybody can toggle this between resolved and unresolved. This is a public option, but typically it's whoever starts the thread and is satisfied with the discussion that goes on in it. They can hit resolved when it doesn't need any more additional follow-ups. I like Piazza's interface. It's not perfect, but I found it pretty effective over the years. As far as for computer science classes goes, I think the Q&A format is pretty effective. So I really encourage you to use Piazza and go to Piazza whenever you have questions about the content, about the assignments, about the quizzes, about the exams, and post things that you have questions for that other students can then help you with. I will be actively monitoring Piazza. I'll be checking it every single day pretty much, and I'll try to answer your questions as best I can. But I do want you to answer other students' questions as well, so we can have a sort of semblance of class community and camaraderie as we work on these assignments together. Generally, if you do have a project or class question, the fastest way to get an answer is on Piazza first, because there will be other students who are looking at Piazza and capable of answering a question. I'll be checking daily, and Piazza will also be a place where I make announcements. So in Piazza, my view actually lets me email you all at once, and I'll be doing mass emails for every single lecture or other important details and announcements through Piazza. So not only will you get an email notification every time I send those out, you'll also see a post here on Piazza. I like to use Piazza more than I like to use Canvas. I think the interface is a little bit better than Canvas. Canvas discussion interface isn't really all that conducive to good discussion, I feel. Piazza is a bit more compact and easily readable and has some better code formatting tools that makes it easier to say certain things, especially for a computer science course. So we'll be using Piazza for everything. We'll be using Canvas for pretty much only the administrative and grading things. But I wouldn't go to Canvas to look for discussion or class announcements. Please do look on Piazza instead. Now, if you have a question that's not suited for Piazza, don't hesitate to email me. I'll try to respond to you within 24 hours. If I don't get back to you, please send me a reminder follow-up email. I apologize if I don't. Sometimes I can respond to you very quickly. Sometimes it can take a while. I do have a full-time job, so I'll try to balance my responsibilities for you all as students and the things I'm doing, to make a living. Don't hesitate to, again, send me a reminder email if I don't get back to you. Sometimes I can get back to you really, really quickly, so don't hesitate to email me in general if you have questions. This class will be graded out of 1,000 points. Each point is worth 0.1% of your final grade for a maximum of 100%. Every point counts. So the breakdown of the class right now is it's going to be 5 total projects with a total value of 100 each for 500 total as far as projects go. There's going to be 2 exams that are worth up to 200 points each for a total of 400. And there's going to be about 20 quizzes in this class that are 5 points each for a total of 100. All those added up together are 1,000. The grading scheme is intended to reflect how well prepared you are for a programming job or advanced computer science course. And I'm going to say up front right now, it's not going to be curved. I know that's kind of a harsh thing to say, especially in the circumstances that we're taking this class in, but I want to reassure you that the grading scheme is actually, I would say, quite generous in some ways. There's going to be several opportunities for bonus points. Every single project has a chance for bonus points. Some of them have more than others. The exams are always worth actually a little bit more than 200 points each, so you can technically exceed this baseline 200 number. And as far as quizzes go, if we don't get to 20 quizzes by the end of the quarter, which is pretty likely, you get the rest of the points for free. So what I want for this to be like is that your grade is a function of the effort you put into this class. And I want to make that correlation very clear. I don't want us to be in this kind of murky scenario where I have to curve everyone's grade in a way that almost makes it unfair for certain students who do really well, but didn't have to actually expend all that effort. So I can save some other students who aren't doing so hot. Again, I'm here for you. I want to support you throughout this endeavor. I don't want to make it a pain in the ass to talk about grades. So I want to make this as straightforward as possible. Just expect the grade that you're going to get. And if you need help, don't hesitate to ask and get help from me during office hours or over email or via Piazza. Your final grade is going to be rounded to a 4.0 scale to meet this Seattle College's standard grading system. It's going to be computed as this Excel formula, which is essentially rounding to the 10th, points minus 600 divided by 100 plus 0.4. So the long story short of this is that you need at least 600 points to get anything. And the cutoffs for an A and A minus are 945 points and 905 points inclusive respectively. And if you click on this link here, you can see a big mapping of what your numerical point grade is to your actual 4.0 scale grade is. I like this point system because it makes it very clear what everything is worth. You don't have to do any additional math in your head that's like, what do I need to get on grade X percentage-wise to make a X to make a grade Y in this class. I like the system. I think it's pretty straightforward and deliberate, and I hope you enjoyed as well. I want this grading to be transparent. I don't ever want you to ask a question of will I or will I not make it, because it's ambiguous what your final grade is going to be. Grades for all assignments should be expected on Canvas within 1 week of the original due date. If there are delays in grading, I will let you know via Piazza announcement. I try to get these grades back to you as soon as I can, so do hold me responsible in that aspect. I don't ever actually remember a circumstance where I turn in grades late, so I think we should be in good shape this quarter for you to get your grades back on time and get that good feedback. Daily quizzes. So with every single lecture, I'm going to be posting a short quiz alongside it that's going to go over the content from the last couple of lectures. The quizzes are a great way to checkpoint your progress throughout the course and make sure that you're staying on top of the material week over week. The quizzes are usually multiple choice. They should take you no longer than 5 minutes, and you have access to all the course material and notes, so they should be pretty straightforward. The quizzes are going to be all collectively due at the end of the quarter. That means you technically don't actually have to take it on the day of the lecture. In fact, you don't have to take them at all until the very, very end. But I really don't recommend you do that. I want you to take the quizzes week over week so you actually get to evaluate your progress as the course goes on. If you save them for the very end, it can be kind of daunting and annoying because you suddenly have all these quizzes that you have to go through in one swoop, and I really don't want you to forget to take quizzes and leave points on the table. These quizzes are, again, going to be pretty short. They should probably take you no more than 5 minutes each, and they all are going to be multiple choice, so they should be pretty straightforward to do. Let's talk about the readings. I've got these two made-up quotes here that I like to say. The first one, "The readings are for your own good," my professor years ago. I'll just skip the readings, me years ago. So reading is often less interesting than doing when it comes to programming, so I've picked short weekly reading assignments that I hope that you will find interesting, useful, and relevant. Please finish these reading assignments before the first class of the following week. I really do feel you in the sense that I want to minimize the overhead it takes to take this course. I was a student not too long ago. I got a lot of reading, and what I discovered was most of the reading that I had to do was not really useful compared to the actual content I got at the lecture. So in this class, I want to do the opposite. I want to give you readings that actually are relevant. I want to give you readings that don't take you too much time. I want to give you readings that I think are actually useful. So I do encourage you to do these readings. I will ask you about them on quizzes. I will ask you about them on exams, but they should not take too much of your time, and I think that they will actually be interesting and useful. I've talked about the textbook for this class and how I don't want you to pick one up because it is unnecessarily expensive. If you do like having a textbook on hand, I suppose you can get one, and I can give you guidance on what chapters to read week over week if you'd like, but I actually actively discourage picking up the book because it costs money, and the internet is an amazing resource that has everything you need to stay up to date with whatever content you need in this class. So don't buy the textbook. Now let's talk about the projects. There's going to be a total of 5 Java projects in this class that you'll complete throughout the quarter, starting with Project 0. All projects are going to be due on Canvas at midnight 2 weeks after they're assigned, except for Project 0, which is going to be due within 1 week. That gives you 2 weeks of office hours and 4 total lectures to ask project questions. Each project is going to explore implementation and application of topics discussed in the class, and I intend for them to be interesting challenges rather than frustrating busy work. Every project is going to come with a JUnit test suite and an autograder script that will determine your project grade contingent on submission correctness. I reserve the right to adjust your project grade based on whether your code is actually correct and meets the project specifications. So when you start working on those projects, you'll find that inside not just the starter code that I gave you for the projects, you'll also see a complete test suite that will evaluate the correctness of your projects based on certain test conditions. I'm going to determine if the interfaces are met and those interfaces provide the correct functionality that I've defined in the project specifications. And then based on the number of tests that you pass out of the number of tests available, your grade is going to be determined out of 100 points total. The great thing about this format is that it means you can check your progress over time. And the tests are written in such a way that You will start simple. The tests begin very simple, and then over time, as you contribute to your project and make it better, you're going to start passing more and more tests for your grade to go up and up. I think this provides a lot of transparency around the grading process. I don't want to introduce very much subjectivity in how I grade your projects. I don't really have strong opinions on little things like how you should format your code or like what your variables should be named. I think those sort of opinions are better suited for you to come up with on your own and determine as you advance in your programming profession. So I will be reviewing your submissions. I'm not just going to grade it and submit it for correctness. So you can't just produce the answers on the tests that the tests expect. You can't just make like a giant if statement that's like, if this, produce that based on the tests. So you can't cheat, even though the grader script may give you, a good amount of points. So I reserve the right to adjust your grade based on how correct your submission actually is. But for the vast majority of the time, the grading script that you'll find contained within the projects, which we'll go about pretty soon, is going to be the accurate reflection of what your grade will be for the project itself. There's some instructions below on this syllabus website where you can find installation and IDE setup instructions. These projects are going to work for the IntelliJ IDE out of the box. And there's some more instructions that go over some more details on how you can actually set that up if you have trouble. Now let's go over late submissions. At a bare minimum, your code should compile and run the test script to get any credit. A lot of the starter code is not going to compile out of the box, so you're going to have to fix it up on your own. And I don't want you to just submit plain starter code as a way of getting some number of points. I'm not going to give you any credit for that. If your submission doesn't compile or does not run to completion via the run script, it's going to be considered late until it's resubmitted and fixed. And if I run into this while grading, I will contact you on Canvas if this is the case. If a submission is late, it's immediately subject to a 25-point penalty, and every additional 24-hour window that passes after the deadline is going to impose another 25-point penalty on your final submission. Submissions over 72 hours late are not going to get any credit because there's not going to be any more points left, and they're not going to be graded. There are not going to be exceptions to this policy. I've heard every excuse in the book. I was a student in the past as well. I understand that mistakes can be made. It can be hard to get things done on time. It's very easy to procrastinate. I don't want to hear it. Please don't BS me. Like, I've heard everything. I have plenty of stories I can share there. But I do want you to do things on time. And as far as me respecting you and that giving your grades back as soon as possible, I'd like you to respect me in turning things in on time. Now, if there's some extraneous circumstances that you do have to deal with in your life that get in the way of this class, please contact me. That is something that, I want to have a discussion with you about. But in general, for the vast majority of the circumstances, I really don't want to hear excuses as to why you turn things in late. Just take the L, take whatever penalty you have to, and try to turn things in on time next time. Again, the grading scheme in this class is intended to be transparent and straightforward. There's going to be opportunities for you to make up points in this class that you may have missed via bonus points, whether it's on the exams or in the projects. And so part of the math that you can do in your head is, given the grading script and what it's telling you about a project now, is if you have to take an extra day, then maybe it's worth it to you because you can make up those 25 points that you lose thanks to the late penalty via whatever points you can make up by gaining ground on your project. I really hope it doesn't come to that. Again, I really want you to work on these projects and actually turn them in on time, but I want the grading itself to be transparent enough so that you can actually make the decision on your own time if you'd like. Let's go over the exams. Since this is an online-only class and I cannot prevent you from reading documentation and checking over your notes while you take the exams are going to be open book and open note, and you can check whatever resources you'd like. So yay. The exams are going to be conducted through Canvas, essentially as long-form quizzes. There's going to be 2 of them total, one in the middle of the quarter and one at the very end. They are going to take you about 2 hours to do if you just blast through them, but you're actually going to get a decent amount of time to actually do them. Generally about 3 days. I'll give you about 3 days to start the exam and actually turn it in. So there will be a deadline for the exam, but you have a very wide window to actually take the exam. And once you start, there's no time limit to actually turning it in. So one good strategy is actually starting as soon as the exam releases, looking at it, and then picking a bunch of answers and then waiting, so that if you change your mind on certain answers, you can do that before the exam is finally up. That being said, if you do turn in your exam, which you'll get like a very preliminary grade for the multiple choice parts, you can't turn it in again. So, submit your exam when you feel like you're ready. And it's actually okay to wait till the very end and just submit it once the deadline is reached. The nice thing about Canvas is it'll actually save your exam progress if you close it and come back to it. Again, it's essentially like a long form quiz. So you can save and resume and take your exam over multiple days if you'd like. But again, the exams will be due on one point. The exam will be due in such a way that it'll be automatically submitted when that time point passes. So do make sure your submission is actually ready before the due date. Software and tools. All the programming projects in this class are going to use Java. Specifically, we'll be using Java SE11 and JUnit 4, which I'm actually going to have built into all the projects, so you don't have to worry about JUnit. You must use the correct Java version for compatibility guarantees, but you are welcome to use whatever operating system and IDE for writing Java code, so long as it runs the test suite itself. Grading scripts are going to be available for both Windows, run.bat, and Mac or Linux, run.sh. When searching for Java documentation, make sure to include 11 because a lot of search engines will return 8 by default. And the APIs can be a little bit different between those two versions. When installing Java 11, I recommend the Adopt OpenJDK releases. These nice installers will get you Java and have it attached to your system in a way that's pretty straightforward. You don't have to make an account on oracle.com to get Java. The reason we're using 11 is because 11 is called the long-term support version of Java. 8 was the older one, 11 is the newer one. And that means Java 11 is going to be supported for a longer period of time than any of these other intermediate versions of Java. Now that does mean we're going to miss out on some of the latest and greatest Java language features. But for the vast majority of things, we are perfectly happy with the APIs that 11 provides. I think 11 provides a good step up over 8, which is perhaps the more popular one right now, because just for legacy support, which is why I picked 11 for this course, so that the things you learn for this class will still be usable for years to come. I've attached a download to JUnit, which is a Java test framework, here if you'd like to play with it on your own, but every project is going to come with it built in, so you don't actually have to download it individually. Oh, hello, Peaches. Meow. Say hello to Peaches. She's my cat. She'll probably interrupt a lot of office hours, and she really loves attention, so, well, hello. The IDE I recommend for this class is IntelliJ. IntelliJ Community Edition is free, and it comes with a lot of really modern language integration features that I think are super valuable, including test suite integration and a super powerful debugger. All of the lecture videos, or almost all of them, will be conducted with IntelliJ showing, and I'll walk you through how to navigate the IntelliJ interface over time. Of course, you are always welcome to use any editor of your choice, such as Eclipse or VS Code or BlueJ or whatever you like, but I really recommend you use IntelliJ, and the skills that you learn in IntelliJ will translate over to these other IDEs as well. As a bonus, all the projects them being written in IntelliJ mean they will open up and should run out of the box as soon as you download them and open them as IntelliJ projects. The last category of software I have listed here is Git, which is a version control system. And we'll talk about why version control is valuable pretty soon, but as far as downloads go, to get Git, I recommend you go with the command line version. There are some GUI, graphical user interface versions of Git, but they tend to abstract away the underlying actions that Git is actually doing, and I would actually recommend that you learn these underlying Git commands so that you can more finely tune the versioning of your software as you develop it. In the past, I've had some trouble with students have had trouble with submitting their projects with their Git folders included when using the GitHub application because it abstracts away some of that version control storage when you use the desktop app. So I'd much rather actually let you have you use the command line interface with Git because it gives you much more fine-grained control over what's actually happening when you use version control for your projects. You can test out your Java install by opening up your terminal, whether that be the terminal application for Mac, probably bash on Linux, and command prompt on Windows, and running java-version and javac-version, and you should get the version number 11 on the way out for both of those commands. Let's try it now. I'll go ahead and open my bash on Ubuntu on Windows and run java-version, which gets me 11, and javac-version, which also gets me 11. This would be what you would see on Mac and Linux. If I switch to the Windows command line prompt, cmd.exe, I should get the same thing with javac-version and java-version. Now let's talk about Git. Git is a version control system designed for tracking software product development over time. With Git, you can commit, view, and revert changes in your project code like a time-traveling backup system, encouraging experimentation without fear of making breaking changes, because you can always go back in time to get an older revision of your project. I really recommend you learn Git for this class, as it will benefit you now and forever onwards. We're going to be learning some simple command line Git during the first week of class. There's also several excellent tutorials online that I have listed here that will go further in depth. Perhaps the easiest way to use it is via GitHub for desktop. That's GitHub's graphical user interface for Git, but again, I recommend you use the command line version of Git instead, so it gives you more fine-grained control of what's actually happening. Now, using Git and learning Git is optional in this course. However, if you do submit projects with a .git folder included and an active commit history, you'll get to earn +5 bonus points on every single project submission. If you do choose to store your repositories in the cloud, such as on GitHub or Bitbucket, please make sure that these online repositories are marked as private so that you don't expose your code to the world and the other students in the class. Finally, let's go over some administrative policies. In the online format, be excellent to each other. Don't be mean. Please don't cheat. If you're caught cheating on any assignment, you and all parties involved will immediately fail the course. I use automated diffing tools to catch potential plagiarism and excessive code reuse between students. Do your best work. Ask for help if you need it. Don't try and consult online third-party sources for existing solutions to the code base, to the problems that I give you. That's really not worth it. I really want you to learn the material, and I want to provide the resources that you need so you can actually learn it, not so you can just steal whatever content you can find and try and get a passing grade that way. We have reasonable accommodations for religion. If you may be absent from course activities and seek reasonable accommodations, but you must make these requests to me in writing within the first 2 weeks of the quarter. And finally, I welcome any and all instructor feedback that you have for me as far as making the course better. You're welcome to email me or speak to me, I guess during office hours, if you have suggestions or concerns about class policies, assignments, or exams. You're also welcome to leave anonymous and constructive feedback on Piazza, and I can address the feedback to the class. Speaking of anonymous posting on Piazza, it is something that is enabled. You can post questions without fear of other people judging you by posting anonymously. That being said, do not abuse this power. If you use the anonymity as a shield to post mean things about me or other people in the class, I can revoke this power for everybody, such that you always have to reveal your name when you post. So, just be a nice person. I don't think that's particularly difficult ask. And you'll be safe to post anonymously if you'd like for questions about the class or anything else. Okay, that is the syllabus. If you have questions, you're always welcome to ask on Piazza or email me for clarification. In the next video, we're going to learn some actual content and get started on some technical topics. So see you then.